Hello students, we are discussing integration by substitution, and now we will take examples where the function to be integrated is algebraic in nature. Okay, let us see the very first example. It says evaluate the integral 1 upon x plus x raised to minus n dx. Let's copy the question. Now students, the very basic thing which I can think of here is writing that x raised to minus n in a different form. So let us proceed to do that. So we have is equal to 1 upon x plus. Now in a different form means we'll go to 7th standard, which says a raised to minus m is equal to 1 upon a raised to m. So likewise x raised to minus n will become 1 upon x raised to n. Is that okay? Now students, the next step is also pretty obvious. The next step is taking LCM. So let's take LCM in the next step to get 1 upon x raised to n into x plus 1, the whole divided by x raised to n. Do not forget this x raised to n. Obviously the dx has to be there. Fine. In the next step, can I say that x raised to n can come in the numerator? So let me just copy the last step for our reference. Now, to rewrite, can we write x raised to n dx in the numerator, and the denominator will be written as x raised to n plus 1 by law of indices. Fair enough? Now students, you need to observe a very important point. We are discussing sums where the function to be integrated is algebraic, and here we observe the difference in the degrees of x in the denominator and numerator is 1. Very important observation. Difference in the degrees of x in the numerator and denominator is 1. To be very precise, power of x in the numerator is less than the power of x in the denominator by 1. In such a case, we substitute the denominator as t. So let us write, let x raised to n plus 1 should be equal to t. Next step is obvious, differentiating with respect to x. We get n plus 1 into x raised to n plus 1 minus 1 dx is equal to dt. Obviously the plus 1 minus 1 should cancel. So we have x raised to n into n plus 1 dx is equal to dt. We can rearrange to write x raised to n dx is equal to dt upon n plus 1. Now we have substituted, we have differentiated. Let us substitute or let us give these changes in the given integral. What was the given integral? It says x raised to n dx upon x raised to n plus 1 plus 1. Now students, can I say the denominator here is t? So can we write 1 by t? And in place of x raised to n dx, can we write dt upon n plus 1? Correct? N plus 1 is a constant, so you will find that outside the integral, and what is left inside the integral is 1 by t dt. And students, we very well know integral 1 by t is log mod of t. So here we get 1 upon n plus 1 log mod of t plus c. Now we need to just resubstitute the value of t. Integration is over. So let us resubstitute 1 upon n plus 1 log mod of x raised to n plus 1 plus c. And that's our final answer. Now students, some more sums which are of the same type. So these sums also have the difference in the degrees of x in the denominator and numerator as 1. So you may try these. Let's take another example. The question is right in front of you students. Let us observe something. In this case also, if you observe, the degree in the numerator and denominator differ by 1. And we saw in the previous sum, that is a very important point which we need to observe, and in such case we substitute the denominator as t. So let us write, let x raised to e plus e raised to x is equal to t. Obviously the next step is differentiating with respect to x. On differentiating, we will get e raised to x plus e into x raised to e minus 1 dx is equal to dt. Now students, if you need to adjust the derivative, just take e common. So if I take e common, we get e brackets e raised to x minus 1 plus x raised to e minus 1 dx is equal to dt. So can we say that e raised to x minus 1 plus x raised to e minus 1 dx is equal to dt by e. Is that okay? So let us give these changes in the integral. And this is the given integral with us. It will become as 1 by dt into 1 by e. That's what we have here. 1 by e upon t dt. Again 1 by e is a constant. So can I take 1 by e outside? Is that okay? What is left is 1 by t dt. Now integral of 1 by t is log mod of t. So can I say it is equal to log mod of t plus c? Now what we need to do? Resubstitute t. And in this case the value of t was e raised to x plus x raised to e. Obviously plus c has to follow. That's our final answer. And some sums based on this. Can we have them? These are the questions which you can try on the same lines. Thank you very much.